So, performance, and I guess obviously we have performance numbers for the water demo in here. We also have some directed tests, and these tests are designed and targeted at sort of stressing the geometry subsystem. So they're not doing necessarily very, very sophisticated pixel shading, because what we wanted to do is measure the performance of the geometry component of the system. And what we did was, what these performance numbers are these tests which we wrote, which are designed to stress geometry, compared against 5870, just to be straightforward. And obviously we see some significant advantages in terms of ranging from 2 to 6.5x performance over that. Also, the hair demo 3 times, the water demo is sort of 4x performance, just running the same code on the 2 parts. And then finally, this is just titled Game State Bucket. What this is well, let me explain what a state bucket is. A state bucket is a period of time when the chip is a batch of geometry with fixed state. There aren't any changes of state coming down, so you can think of it as a draw call if you've written programs where there aren't any texture binds, there's nothing else going on. It's just a setup, and you just pump a bunch of data through it, and you can measure what's going on. So for this particular sort of fragment of the frame, we see roughly 6x performance advantage. And I attribute, frankly, we've been spending a fair amount of time recently trying to understand, it may sound funny, but why we're so much faster.
Yeah, so let me interject on that. I mean, it's not, we're not trying to criticize ATI too much. I mean, this is probably, if we had done what we were talking about G200, we would have gotten similar results, I expect. It's fairly straightforward, right? If you only have one setup engine, and the setup engine has a certain amount of performance, there's just a certain amount of geometry to really push in the system. So these tests basically are tests that are just pushing on that geometry horsepower, and if you have a chip that has more geometry horsepower, the more geometry you draw, the better it's going to go.
Yeah, I mean, there are a bunch of different facets of the design, which to some degree it's impractical to get into all of it today, but that we did to make the geometry processing efficient. We've highlighted probably the most critical ones, the ones that make orders of magnitude difference, but we put a lot of effort into making this work well. So,
and it's just, people make different choices. This was the choice that we made, was to really push up this part of the pipeline, and we thought it was a logical thing to do, because that's really what DX11 tessellation is all about, is drawing lots of